So in this video here, we're going to look at the basics of hydrocarbons. Hydrocarbons are compounds that are found in crude oil. Crude oil is found beneath the Earth's crust. It's formed over millions of years. It is a mixture. It's a mixture of different hydrocarbons. Okay, now a hydrocarbon is a compound that contains only carbon and hydrogen. This is an important definition. Now I've got this table here. It shows the first three members of the simplest hydrocarbon family, the alkane family. We've got methane, ethane, and propane. The formula for the first one is CH4. Carbon always forms the backbone of these compounds. Carbon is in group 4 of the periodic table, so it's got 4 electrons on its outer shell. So it wants 8, so it forms 4 covalent bonds, 4 shared pairs of electrons to fill its outer shell. Hydrogen only has 1 electron in its outer shell, so it only forms 1 bond to fill its outer shell. So we've got 4 bonds around the carbon, 1 bond around the hydrogen. Now, next one is ethane. So carbon always forms the backbone of the compound. So we've got 2 carbons in the backbone, surrounded by hydrogens. And the next one is propane, where we've got 3 carbons. Okay, so every member of the family goes up by 1 carbon each time, and a couple of hydrogens. And the chain just gets longer and longer. It goes up to about 40 carbons long in crude oil. So I've got C2H6 there and C3H8. If we count all the hydrogens, there's 8 hydrogens around that. Now we've got a new naming system here. Meth means 1 carbon, eth means 2 carbon, prop means 3 carbons. Okay, let's write that there because you need to know it. Meth equals 1 carbon, eth equals 2 carbons, prop equals 3 carbons. If you're doing separate science, triple chemistry, you need to know bute as well. Bute is 4 carbons. So if ever you see a molecule starting like eth or eth, depending on how you pronounce it, that means it's got 2 carbons in its backbone, if you like. These are all covalent bonds. Okay, just to draw the methane bonding diagram, just revising the bonding module. Carbon's got 6 protons in its nucleus. Its atomic number is 6. That means it's got 6 electrons, 2 on the first shell, and 1, 2, 3, 4 on the second shell. Hydrogen's just got the 1, so it's only got 1 shell. Okay, and so it forms. It only needs 1 extra to fill the outer shell because the first shell holds 2 electrons, so we've got hydrogen surrounding it. So that's how we drew. Methane when we did the bonding module. Okay, just for speed now, we're going to represent that like this, where every line is a shared pair of electrons, a covalent bond. Right, so next page. I'm not going to draw the ethane one. Right, now this one here. Draw a diagram to show what a mixture of hydrocarbons and crude oil would look like. Okay, so if we get some crude oil out of the earth, it's going to be a complete mixture of all of these. It'll have some methane in it, some of that. Okay, it'll have some, butane in it. Butane is 4 carbons. Now, I'm not going to do this for too long because I'll be here for hours. Okay, has some butane in it. That molecule. It'll have some octane in it. Octane is petrol. That's 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8. As I said, we just need to keep drawing different length molecules, okay, up to 40 carbons in length, because basically crude oil is a complete mixture of all these. It's a mess. They're all mixed in together, okay, and before we can use it, we have to separate. So that's octane. And, you could do a 40 carbon long one on here, okay? You need to draw, if obviously there's billions and billions of molecules, even in a few milliliters. Okay, but yeah, crude oil is a complete mixture, and that's the important point. It is a mixture. Okay, and before we can use it, we have to separate that mixture. We'll talk about that in maybe the next video. Look at the 2 hydrocarbons below, then decide which is easy to ignite, high boiling point, viscous, and in demand. Okay, so different hydrocarbons have different properties. Now those properties are linked to the chain length. So here's a medium-sized hydrocarbon. It's probably about 20 carbons there if we count it up. Remember, there's about the hydrocarbons in crude oil get to about 40 carbons in length. And here's a very short chain hydrocarbon, only a couple of carbons. Now, depending on the length of the carbon chain, it depends on how flammable, how easy it is to set fire to it, how easy it is to ignite it. Okay, now when I ask classes what their gut feeling is, most people tell me they think this one's easier to ignite, and they are right. Okay, because the shorter the chain, the more flammable it is. Likewise, which one has the higher boiling point? Well, every one of these carbons in this molecule will attract another molecule. So the more carbons there are, the more attraction. So this one therefore has the higher boiling point. Okay, so the longer the chain, the higher boiling point. And again, most people's gut feeling tells them the longer, the bigger the molecule, the higher the boiling point. Viscous. Viscous means how thick it is. So golden syrup or treacle is viscous. Okay, most people tell me that they think this one is the more viscous one, and they are correct. Okay, more in demand. Well, generally as humans, we desire ones that we can set fire to easily. So we want the shorter chain ones. So we want less of the longer chain, more of the shorter chain. That's important. Okay, so we've got some definitions now. Chain length. Okay, number of carbons in the molecule. So you'll often hear your teacher, I'm sure, talk about the carbon chain length. And we're talking about the number of carbons in the molecule. Ease of ignition, how easily it catches fire. Boiling points, temperature it boils at. Okay, is the boiling point high or low? Do we need to put a lot of energy in, or a little energy in to turn it into a gas? Viscous, how thick it is. In demand, how much use humans have for it. We burn hydrocarbons, so we want the flammable ones. How much use humans have for it. Okay, and that's all these are linked to all these four are linked to the chain length. Okay, so short chain, ease of ignition, high. Long chain, ease of ignition, low. Boiling point, low for short chain, high for long chain. Viscosity is low viscosity for short chain, high viscosity for long chain. Short chain in demand, high. Long chain in demand, low. Which length hydrocarbon will be best for a fuel? Okay, we're after the short chain ones because they burn easily, they flow easily, they ignite easily. Okay, so that's the short chain one, and you can fill that in with a bit more, with some reasons for your answer. Okay, so in the next video, we're going to look at how we separate this mixture of crude oil, this mess of crude oil.